Hello everyone, welcome again. So in the last couple of videos we talked about the theoretical pricing model, and we now know that there are several assumptions that go into the theoretical pricing model, and even with the best guess we can make, we are still talking in terms of probabilities. So if our assumptions are good, we have a high probability of success. If our assumptions are not good, we might lose money. But here is the thing to note. Even if all our assumptions are correct, it's possible that conditions might change over a period of time, and that can affect the value of the option. A lot of option trader education is about learning how the changing market conditions affect the option value, and there are things, there are values that, so this is how the value of the option might change. It might change because of the value of the option will change depending on the value of the underlying. It might change because of the volatility. It might change because of the passage of time, and it might change because of the interest rate. And for an option trader, it's important not only to understand the directional effect but also the magnitude of the change. And there are some numbers which help us better understand these changes, both in magnitude and direction. And these are what I'll call Greeks. And there are Greeks associated with each of these variables. There is a Greek called delta, the value of the underlying. There is a Greek called gamma. There is a Greek called vega here, that is associated with volatility. There is a Greek called theta, and there is a Greek called rho that is associated with the interest rate. And I would start by talking a little bit about delta. Okay, so what is delta? Delta, it is a measure of how an option's value changes with respect to change in the price of an underlying. So it's a measure of how an option's value changes with respect to change in the price of an underlying. Delta has a range. It varies from 0 to 200 in case of calls, 0 to minus 100 in case of puts. So how do we read this? First of all, let me tell you, there's a common notation that is used. Delta, if you go to a website and if you go to probably CBOE, Chicago Board of Option Exchange, and you might see the value of delta. Okay, this you might see the value of, something is funny. You might see the value of delta as say 0.30, but it's in common terms, in common notation we take out the decimal points. So when we refer to, we can notice that the position has a 30 delta. So what does a delta mean? So a delta means the figure of 0.30. It means that if the underlying rises by 1 point, this is the underlying here, if the underlying rises by 1 point, the value of the option would go up by 0.3. and remember, we are talking about calls here. So if a delta goes up by if If the underlying goes up by 1 point, the delta goes up by 0.3. If the delta is 0.65, which means it'll mean that if the underlying goes up by 1 point, the option price will go up by 0.65, and that is a call option. And again, some important things to note is that in the money options, have a delta of deep in, if I just mentioned deep in the money options have a delta of 100, at the money options have a delta of 50, and deep out of the money options have a delta of 0. And so if you look at the graph, this is how a delta would look like. Suppose I have an option here that an exercise price of $40, 40 over here, say 50, 60, 70, and the values decreasing over here, 30, 20, and this is the delta, say 100, 50, 0. So if we plot the value of the graph of a delta of a call option, this is what it will look like. So what it means is that as the value, this is the XYZ, the underlying, and this is the delta. What we see is that as we go deep in the money, the delta approaches 100, and as we go out of the money, this is the out of the money, the delta approaches 0, and at the money, this is here, at the money, the delta is 50. So this is how we interpret a delta. And just to remember that for an underlying, the delta is 1, or if it expressed in terms of decimals, it is 100. These are some of the things that we know about delta. And again, if we talk about puts, the range of delta for puts is 0 to minus 100, and it's what it means is that suppose there is a delta of 0.25 for a put option. That means if the underlying goes up by 1, the value of the put option will go down. The value of the put option will go down by 1. And again, same thing over here. I can draw a graph for the delta of for a put option. Again, instead of, it'll change to minus 50, 0, and everything will remain the same. I'm sorry, it should have been here. It should have been more here. This is at the money, deep in the money, delta approaching minus 100, and out of the money, here, out of the money, the delta approaches 0, and this is XYZ increasing. This was for a $40 put, $80 here, 0 here. And we'll talk more about the properties of delta in the next video.